Good morning everyone. Today we will discuss about Cockcroft Walton circuit. Basically it's a voltage multiplier circuit used in high voltage systems. Using this circuit we can get output voltage multiple of the input voltage. Now coming to the construction of the circuit, we can see in between any two junctions there is a capacitor. Between these two junctions there is a capacitor. In between these two junctions there is capacitor C3. Similarly in between these junctions C2 and C4, like this. Like capacitor, we can place diode in such a manner that in 1/2 cycle of the AC supply one diode will conduct. So we have placed diode D1 in between these two junctions, and in between these two junctions diode D2, and in between these two junctions diode D3 and D4. Now coming to the working of the Cockcroft Walton circuit, we can see, let's consider for the positive half supply of the positive half cycle of the AC supply. Let's this terminal is at positive potential and this terminal is at negative potential. So this junction is at positive potential and this junction is at negative potential. So in this condition the diode D1 becomes forward bias because anode of the diode is connected with the positive supply and cathode of the diode is connected with the negative supply. So the diode will conduct in this. The circulation of current will be like this. So the capacitor C1 for the first half cycle will be charged up to a voltage maximum Vy equal to the input voltage Vi. So at the end of the first half cycle the voltage across this capacitor is equal to the input voltage Vi. Now for the next half cycle the polarity of the input source will change. Now this terminal will be positive and this terminal will be negative. So in this condition diode D1 will be reverse bias. This is negative and this is positive. Now this junction is at positive potential and this junction is at negative potential. So this is positive and this is negative. Now at this condition diode D2 is forward biased. So the circulation of current will be like this. Through the diode D2 through C2 it will reach the negative terminal of the supply. Now the capacitor C2 is getting a voltage which is equal to the summation of input voltage plus the voltage across the capacitor, that is capacitor C1, that is Vi. So input voltage Vi plus capacitor voltage Vi. So 2 times Vi it will get the supply voltage. So at the end of the half cycle we will get the voltage across capacitor C2 which is equal to 2 times the input voltage. Now at the end of this half cycle again the polarity of the input will change. So this terminal will be at positive potential at this and this terminal will be negative potential. So in this condition this is negative, this is also negative, and this one will be positive. Now we can see diode D1 is at forward bias, diode D2 is reverse bias, diode D3 is in forward bias condition. Now the current will circulate like this. positive terminal of the supply voltage, capacitor C2, diode D3, capacitor C3 through C1, it will reach the negative terminal of the supply voltage. Now this capacitor C3 is getting a supply voltage which is equal to the voltage stored across the capacitor C2, that is 2 times the input voltage plus the input voltage, both are in series. So the C3 capacitor C3 will be charged up to a voltage 3 times the input voltage. Now after this half cycle, again the polarity across the supply terminal will change. Now it will be positive and it will be negative. The voltage across this capacitor C3 was 3 times the input voltage in our last cycle. Now this junction is at positive potential and this junction is at negative potential. In this condition, diode D4 will come to forward bias condition. So the direction of current will be like this: C1, C3, D4, C4, C2 and negative terminal of the supply voltage. Now the capacitor C4 is getting a supply voltage which is equal to the voltage of this capacitor C3 and the supply voltage Vi. So here the voltage across C3 it was 3 times Vi. Now the supply voltage Vi. So this V0 will be 4 times Vi. Thank you.